All right, hello, grade eights. This is lesson 2 in chapter 3. So we are talking about Pythagorean's theorem. So Pythagorean's theorem is all about triangles and specifically right-angled triangles. So we're going to get into it here. So Pythagorean's theorem. So you can see this is Pythagoras here with his pyramid, his triangle. So he was an ancient mathematician, and he figured out this relationship with right triangles that is very important and very useful. So you may be right, Pythagoras, but everybody's going to laugh if you call it a hypotenuse. Okay, so hypotenuse is one of the key terms we're going to learn about in this unit. So first things first, we got to deal with what is a right triangle. So a right triangle has a right angle at 90 degrees. Okay, so 90 degrees, that is what makes it a right triangle. And you can see it's marked with a small square. So all of these triangles are marked with a small square. So this is a 90-degree angle. Okay, so that's what makes it a right triangle. It means it has a right angle or a corner that is a 90-degree angle in the corner. And you can once again see it with the small square. Okay, so we need to know what that is. Next up, we need to know the hypotenuse. Okay, I put a picture of a hippo here because it kind of looks like hippo, hypotenuse, or hypotenuse, but it is pronounced hypotenuse. And the hypotenuse is the longest side of a right triangle, the longest side. So you can see in this drawing here, the hypotenuse is this here, this length here, okay? And it is opposite of the right angle. So that's another way you could remember it. You can see the right angle is down here, right? And the hypotenuse is opposite. It's straight over here, okay? It's opposite of the right angle. So we need to know the hypotenuse. And then the other two sides are called legs. Okay, so that's pretty easy to remember, the legs. So that would be this side here. Let me change up this color, maybe blue. This side and this side are the legs, okay? And the longest side is the hypotenuse. So we need to know that. So if we were to look at these triangles again, we would have the hypotenuse here. And these two would be legs. Well, I guess leg and leg. So that's the deal there. So that'd be one leg and another leg. And that is how we label triangles and their side lengths. All right, let's move it over here. Pythagorean's relationship. So you may be wondering, how does this have to do with what we learned about last time when we learned about squares and square roots and all of that? Well, this is where we get into it here. The Pythagorean relationship. So the relationship is, let me write it out for you, a squared, remember we learned about our squared exponents, plus b squared equals c squared. Okay, so how interesting is this? We are going to unpack this relationship today and in this unit, and it's a very important relationship. So when we're dealing with it, this basically means the side lengths of the triangle. So these two here are the legs, okay, and this is the hypotenuse. So that's how we know and deal with this relationship and label it. So if we look over at our right triangle drawn over here to the side, we can see that we have A, which is this leg here. We have B, and then we have C, our hypotenuse. So what this is saying is A squared. So if we took A, the length of A, and we made a square out of it like this, and we added that to B squared, we would get this area of C squared. So that is very, very interesting stuff. So if we have ourselves a triangle, let's look into how we would solve some areas. So if we knew the side length or the areas, we can see how we would solve. So this is essentially the relationship though. So write this down, make note of it. A squared plus b squared equals c squared. Okay, so let's see here. So if we had a triangle, right? Let's see, I think in the note packet, you will see. So here's our right triangle, okay? So this is going to be our triangle. We'll make sure that it's right. We'll notate it with a square, okay? And then let's say we have squared the sides. Okay, so we've made a square. This might not look like a square, but let's just, for the sake of it, pretend that it's a square. Let's see. Wait, let me do that again. It should make it nice and square, I'm hoping. Nope. Okay, anyways, we'll pretend that it's going to be a square. Sort of square-like. I mean, these look more like a rectangle, but we'll pretend. Okay, and let's say we have 20 centimeters squared as the area, and this area is 32 centimeters squared. Okay, can we figure out what this area is? Okay, well, we know our formula is a squared plus b squared equals c squared. Okay, so let's just say, for the sake of this example, that this is a, this is b, and of course our hypotenuse is always c. So a squared, we know right now, they told us is 20. Okay, so we would have, if we were to rewrite our formula, let's just see, we would have 20 plus 32 equals c squared. Okay, so if we wanted to figure out c squared, because this right here, our question mark, is c squared. So if we wanted to figure out c squared, we would need to simply add these two together. And we could see that c squared in this case would equal 20 plus 32, which is 52. So that would mean that this area here is 52 centimeters squared. Okay, so this is the relationship. This is what we're exploring today. So nothing too crazy. Okay, so let's try another one together. So let's just get rid of this. Okay, so let's say we have a triangle where they give us the hypotenuse. So if we had our triangle, right? Let's say we have our triangle kind of looking like this. I'm gonna make it a little smaller this time. Okay, there it is. Okay, and our hypotenuse squared, whoa. We're just gonna try to sketch this out here. Our hypotenuse squared is 90. Okay, this is 9. Ooh, we're still in shape mode. So this is 90 centimeters squared. Okay, and this side over here is 25 centimeters squared. And what is this one? Well, so if this is A, B, and C, we could rewrite our equation. So let's write this out. A squared plus B squared, right, equals C squared. So these are, A, B, and C are our side lengths. That's a key thing we need to keep in mind here. So C squared is 90 centimeters. A squared is 25 centimeters. And B squared, we don't actually know. Okay, so we could say, let's plug our numbers in. So C squared is 90. So we have 90. B squared, we don't know what that is. So we'll write B squared. And A squared is 25. Okay, oh, so I was about to write centimeters there, but we're just going to disregard the units while we're solving our numbers, and then we'll put our units back in at the end. Okay, so now we have an equation here where we are missing our variable of b squared here. So in order to solve for this, we can use our opposite operations, just like we finished doing in our last unit. So let's do that. So we're going to say, we're going to subtract 25 over here to isolate the variable, subtract 25 from this side, and we are going to get 90 minus 25, which equals b squared. So 90 minus 25, let's see, 70, 65. So b squared equals 65. And we need to make sure we write the units. So we would write 65 centimeters squared. That is the area of this. So you can kind of see it was like a bit of plugging and chugging. And that's how we figured that out. Okay, so now we can also use this to test if triangles are right triangles. Okay, so that was kind of determining the area. Now let's use it to test if it's a right triangle. So if they gave us some numbers, so let's say they gave us the side lengths of our triangle. So let's sketch out a triangle. I would recommend always sketching a triangle in this unit. It'll just help you understand. Okay, so this is our right triangle. And so if they said the side lengths of the triangle are 6, 8, and 10. So 6, oh, I did it again, are 6, 8, and 10. Is this a right triangle? How would we know? So we actually don't know in this case if it is a right triangle. So let me just erase this little thing. We are wondering, is this a right triangle? So we know that right triangles, the Pythagorean theorem is true. A squared plus b squared equals c squared. So let's figure out if this is a right triangle. So let's plug in our numbers. So let's say this is A, B, and C. So we could say 6 squared plus 8 squared equals 10 squared. Okay, so this is what we're wondering here. So if we did 6 times 6, we would get 36, right? 6 squared means 6 times 6. We covered that last unit, so let me just rewrite this again. So 6 squared could also be written as 6 times 6. So 6 times 6 plus 8 times 8 equals 10 times 10. So I just kind of wrote this out in long form just to remember our algebra, what the exponent means. The squared means we multiply the number by itself. So 6 times 6 equals 36, right? 8 times 8 equals, of course, 64. And 10 times 10 equals 100. So now we can see this is this, but is this true? Is this true? Let's see. So 36 plus 64 would give us an answer of, well, 6 would go up to 70 and we would have 30 left. So we would have 100 equals 100. So this is true. Yay! Which means this triangle is a right triangle. Because of the fact that the Pythagorean theorem is true and it worked. Okay, so let's try another one and see if we can figure that out, figure the next one out. And that will be what we're covering in number 1. So let's leave our triangle. Okay, let's get some new numbers. So if they gave us the numbers of 9, 17, and 25 as the side lengths. So let's test this out again. So a squared plus b squared equals c squared. Okay, so a squared is 9. B squared is 17. And c squared is 25 squared. So what I went ahead and did is I plugged my side lengths into our formula. So we can see that we get our formula looking like that. So 9 squared is 9 times 9, which is 81. 17 squared is 17 times 17, which is 289. And c squared is 25 times 25, which is 625. Okay, so now we've calculated this. Now let's see if this is true. And I can tell you already that it doesn't look like it's going to be true because the answer over here is in the 600s, and there's no way we can get 600 on this side. So 289 plus 81 would equal 290 plus 80, so it would equal 370, right? And this does not equal 625. No, nope, this is not true. So this is not a right triangle. So this would be no, not a right triangle, which means the corner is not right. That's what that means. Okay, so we know that. So this is not a right triangle because Pythagorean theorem is not true. Okay, are we following? So let's do one final example, and we will be good for our first Pythagorean theorem lesson. So let's try the example of 10, 24, and 26. Okay, so let's plug it into our formula. A squared plus b squared equals c squared. A squared is 10 squared plus b squared, which is 24 squared, equals c squared, 26 squared. Okay, so obviously 10 times 10, we got ourselves 100. 24 times 24, 24 squared is 576. And 26 times 26 is 676. Very interesting. So if we add 100 plus 576, we end up with 676. Which, these are the same. Yay, it works. So yes, this is a right triangle. Great news. We can put our little right triangle thing there. So that's Pythagorean theorem lesson 1. Hope you are following and understanding. If not, of course, no worries. We're just learning. So send me a message and chat with me in class, and we'll talk to you later.